Hello again, my friends. Now we're going to get into this thing called the chain rule. Basically, this chain rule is when you have a composition of functions, which means you have a function embedded inside of another. In this case, this is my inside function. In, oh boy, I'm going to have one of those days. Inside function, and it is being embedded inside the outside function, the f. And I'll refer to inside outside quite a bit. So now the general rule is you take the derivative of the outside, keep the g of x inside, you don't change that, times the derivative of the inside. So basically I have the dir of the out times the dir of the in. Derivative. Okay. We like to use u. Please refrain from being dumb here, but that's the derivative with respect to x of f of u. fu. All right. So, it's this is how we actually think of it. We're actually going to think of the inside function as a u. So if I take the derivative, I'll take the derivative of the outside times the derivative of the inside. Same idea, but we like this one a lot. We use the u tick, the u prime, because that's just what we do. By the way, many people have acquired nicknames because they tend to forget this part. They forget the derivative of the inside. Um, you'll get good at it, I hope. Here we go. First example. Okay, so we clearly have a function inside of another. You sure as heck don't want to take this thing to a power of 11 and FOIL that out so you can use a power rule or something crazy like that. That'd be a nut case. It's a nut job. I'm not doing that. So what I'm going to do is I'm going to consider this to be a chain rule. What I have to do is first identify the inside. Okay, I'm going to identify the inside as u equals 2x minus 3. That's my inside. Okay, so its derivative is 2. All right, so this is kind of the side work. And my basis here is I've considered that whole inside u. So I'm going to think of this as u to the 11th. Why? Because now I've created a very complicated function to a very easy derivative, u to the 11th. Well, its derivative is 11 u to the 10th. But see, there's a difference here. There's not just, it's not, u is not just x. It's in fact a whole function. It implies you have to take times u tick. Every single time we're doing a chain rule, you're going to see this at the end of your problem. But you have to identify the inside first. Once you've taken the derivative of the inside, you've taken the derivative of the outside, you now just pii, plug it in. 11 times your u, which is so beautifully 2x minus 3, to the 10th, times the derivative of u, 2. All I did was plug in my u and my u tick, my u prime. Look at what you have. I think I can multiply the 22, the 2 and the 11, and that is my derivative. Polynomials are pretty straightforward, but they can get confusing. Now, trig, people just don't understand what that power 3 is. Really, this is a lazy man's way of saying 4 sine x all to the third. You need to identify a power on trig in that way. You must say to yourself, oh, that's the function to the power. So here this is sine x all to the third power. If you visualize this, then of course you can see there's an inside function. Identify it, take its derivative. That's your side work. Now come back over here. Let's rewrite this as a simpler form, u to the third. Take its derivative. And now pii using your inside work. So come over here and grab those two things and plug it into this, and you get 12. You are so beautiful to me, can't you see? Times outside cosine x. All right. With trig, though, however, there's some identities that might come into play here. I'm not necessarily going to show it to you here. I may be showing it to you in class. Uh, 565 is where you'll find all these identities. The first three lines, they're all called the Pythagorean identities. Those are the ones we need. So I will illustrate those as you go through examples. Again, here's an example of a section where if you don't do a lot of practice, you're not going to get good at this. So do all the problems, ask many questions, as many as you need. Next question. Examples. This one, clearly you see something inside. Let's identify it. U equals secant x plus tan x. Let's take its derivative. This is all my side work. Derivative secant is secant tangent, plus the derivative tangent is secant squared x. I can already tell this is going to be a hot mess. Just ugly. Look at all that stuff. All right. So let's calm our giblets down a little bit. Let's look at this again in a simpler form. 4 square root of u. Now, I told you the derivative of this is really u to the 1/2. Now, I could do the power rule that way, but just remember, the square root of u is 1 over 2 square root of u. Now, don't forget the u-tick, of course. So derivative, 4 times. Now, I'm going to take the derivative of square root of u, 1 over 2 square root of u. And lo and behold, if you forget your u-tick, you're in deep poop. All right, anyway, everybody good? Well, thanks for the response. All right, let's simplify this a little bit. First, before I PII, 4 divided by 2 is 2 over square root u times u-tick. So that's the best version of it. And now let's PII, come up here and grab these two things and just simply plug them in. And yes, you get something very ugly. Yep, we probably can factor out a secant x here, but it's not going to amount to hella beans. You wind up with a PII. This is easy. I'm not even thinking here. All I'm doing is plugging it in, and there you go. Now I think a little bit, and I say I could pull out up here. I could probably pull out a common factor of secant x, but that's only if I feel it's necessary. I see the problem is convoluted, or the solution they have is different. Okay, now we get into this thing called a double chain. You got an inside with an inside. In other words, you've got a function inside of another function inside of another function. So there's actually going to be, it's called a double chain. And this is where I'm going to work really hard with you to understand these baby chains, these very simple chain rule things. At the end of the day, we're going to have to do derivatives multiple times. So we're going to need some good skills in that. I'll help you. But let's just look at this real carefully here. Let's look at this. I'm going to rewrite this because I see this power of 4, and that's not really what this is. This is this to the 4th. If you can see this, I mean, if I look at this, I see an inside, but that inside has an inside. That's how I know I have a double chain. You can unfold this like the Russian dolls if you want. So I'm going to kind of walk through this twice. Once very clinically, and the second time using that kind of a Russian doll idea where one collapses upon itself. Let me get rid of that junk real quick. All right, here we go. I believe I first must identify my inside. Take a deep breath because I'm going to take its derivative, but look, hello, it's got an inside. And this is this little dinky thing here, this cosine 2x thing. That's what I call a baby chain. It's just something where you shouldn't have to do any side work for. So I'm going to take the derivative of the outside. There it is. What am I forgetting? Oh, yeah, that thing called the u-tick. It has its own u-tick, too. So there you go. Now that I did my side work, I can come over here and make this a simple little thing like that. I haven't taken the derivative of the outside yet. Here's the derivative of the outside. 12 u to the 3rd times u-tick. Okay, so I have the derivative of the inside. I have the derivative of the outside. Now I'm just going to PII. 12 u cosine 2x to the 3rd times u-tick. Now I'm going to straighten. Now, deep breath. I have it. Now I'm going to look to see if I have to simplify it. I'm going to multiply it's all factors, so I can multiply those two together. Gives me 24. I don't know. Let's rewrite that cosine in normal form. So cosine to the third 2x. So I just rewrote this puppy here, right up here. And now I'm just going to put sine 2x. And I'm going to slap my negative out in front. And there you go. You just did a double chain. Woohoo! Oh, snap. Holy giblet. This looks like a mess. Let's think before we dive in here. Let's see. This one, I think there's a multiplication inside. It's x cubed times this, and this looks like a chain rule. So I think what I'm going to do is I'm going to have to do a product rule because there's a product there. But g is not a simple derivative. It's a chain rule. So we have a product rule with a chain rule inside. This is where setting yourself up for success matters. I'm going to go ahead and write f, my fig figgy. And what's that going to allow me to do? I'm just going to basically find f and f tick and g tick. And that just means I'm going to come back to this and PII. So let's look at f. Here's f. Here's f tick. Easy enough. G, uh-oh. I see an inside. I'm going to have to do some side work. Inside, take its derivative. Outside is u to the fifth, take its derivative. PII, straighten it out. Okay, so now what have I got here? Let's see. I've got my F. I've got my F tick. I've got my G. I've got my G tick. All right. And now this step is easy. I'm just going to PII. Come over here and PIIN. Yai. F tick. G. Okay, there's one term. Plus, now I'm going to write the second term, F times G tick. Okay, that's really good. And we're done, except for, algebraically speaking, this is not simplified. We have uno, dos términos. We have two terms. And what form do we love? Oh, yeah. We love factored form. Both of those two terms, both this term and this term, have some common factors. They both have a 3 in them. So I'm going to pull the common factor 3 out. Now I'm going to look at the next part or factor in each term. I have x squared and x cubed. So they have a common x squared. The next factor in each term is 3x minus 1. There's 5 of them there. There's 4 of them there, which means they have 4 in common. Now, when I pulled those factors out of the 3, it's completely gone. I've taken the 3x squared, it's gone. This term, I've taken 4 of them out. That means I need a leftover 3x minus 1 plus. Over in this term, this factor, I took out 2. That means I have an x left over. This factor in the term, I took out 3, leaving me just 5. 3x minus 1 to the fourth. Well, I had taken out 4 of them. That means I don't have any of them left. So that leaves me with this, the x times 5. I think if I look at this very carefully right there, I could probably straighten that out. 3x plus 5x is 8x minus 1. And then let's copy these other factors down. Hello, I love factored form. QED, which means quasi-epidemonstrator, which means, heck, I'm done. All right. Make sure you do all the practice. You're probably going to get multiple exercises in this, so take advantage of them.